In this video, we're going to discuss solving equations that have radicals in them. So here's an example of a radical equation. We have square root of 11 minus x equals 1. The most common mistake I see when students solve these type of equations is they try to square each term. So they say, oh, I have a square root, I need to get rid of it, so I need to square it. That is what we need to do. We do need to square something, but we're not allowed to square each term in an equation. Let's give a real basic example here. We know that 1 plus 1 equals 2. Now, if we square each term in that equation, what do we get? We get 1 plus 1 equals 4. That's not true. So we can't square each term and still have the equation be equal. What we can do is we can square each side of the equation. So if we say, all right, 1 plus 1 is 2, now I'm going to square each side. Now I have 2 squared equals 2 squared. That's certainly true. So you can't square each term, but you can square each side. So what we need to do then is get that radical by itself first. That way, when we square each side, the radical comes right off. Alright, so let me copy this on a blank slide here. Alright, so we want the radical by itself, so let's add x to each side first. And now that the radical is by itself, if we square both sides here, the radical will come off. So on the left side, we're just going to be left with 11 minus x. Now, be careful on the right side. We just saw that squaring each term is not the same thing as squaring the entire side. If we're squaring x plus 1, that means we're multiplying it by itself. So we're going to need to do some distributing on the right side there. So we end up with a quadratic, and if you've watched the video on solving rational equations, we discussed that anytime you end up with a different type of equation than what you started with, you need to check for extraneous solutions. So here we didn't start with a quadratic, but we did end up with one. Most quadratics have 2 solutions, but not necessarily both of those solutions going to be a solution to our radical equation. So anyway, let's solve this quadratic. So we probably want to set it equal to 0 first. So if we get everything on the same side here, we have 0 equals x squared plus 3x minus 10. And that factors. I'm going to not show the steps of factoring this, but factors is x plus 5 times x minus 2. So the quadratic has 2 solutions, negative 5 and positive 2. We need to now check those in our original equation and see if they are indeed solutions to our original equation. Alright, so our original equation was square root of 11 minus x. So I'm going to check negative 5 first. So I'm going to substitute negative 5 for x. So we had square root of 11 minus x, and that was supposed to be equal to 1. Alright, so what do we have here? We have 11 plus 5, so square root of 16 plus 5. And we want to know if that's equal to 1. Well, that's 4 plus 5 on the left. That's not equal to 1. So negative 5 is not a solution to our radical equation. let's check 2. So if we substitute 2 for x in our original equation, let's see if we get a true statement. Well, we'd have square root of 9 minus 2, so 3 minus 2, which is equal to 1. So 2 is the only solution to our original equation. Alright, so those are the steps for solving a radical equation. We want to get the radical by itself, and then since it was a square root in this case, we squared both sides. It might not be a square root, it might be a cube root or a fourth root or a fifth root. So for example, if you have cube root, you still want to isolate the radical, which has already been done here. But then to get rid of the cube root, you would cube each side. So now we have x plus 1 equals negative 3 cubed, which is going to be negative 27. So we get x equals negative 28. Still a good idea to check the solutions. So if we put negative 28 in for x, we have cube root of negative 28 plus 1, so cube root of negative 27, and that is negative 3. Alright, now sometimes the equation has more than one radical, so let's discuss what we do for those. So here we have square root of 3x plus 4 minus square root of 2x minus 4 equals 2. Now, like we discussed before, we're not allowed to square each term here. And if we square both sides right now, that's not going to help us out much, because if we square that left side right now, we're going to be taking that left side times itself, which means we're going to be distributing, and we're still going to have radicals. Actually, the left side is going to be even more messy than it is right now if we square it. So what we want to do is kind of like before, where we said the first step is get the radical by itself. Here, you want to get one of the radicals by itself. It doesn't matter which one. So for example, we could add square root of 2x minus 4 to each side, and we will be isolating the first radical then. So now that we have one of the radicals isolated, we can square each side. And so on the left side, we're just left with 3x plus 4. On the right side, we need to remember that squaring the entire side is not the same thing as squaring each term. When you square something, you're multiplying it by itself. So we're going to need to do some distributing here. So distribute 2 to each part, and then we'll distribute the radical to each part. Now when you do that radical times itself, it's basically taking that radical and squaring it, because you're multiplying it by itself. So when you do the last times the last there, you do just get 2x minus 4. Alright, let's start combining some like terms on the right side here. We have 4 minus 4, that's 0. We have 2x. And then we have these two terms here. Both have the radicals. So just like if it was 2x plus 2x, you would have 4x. 2 times the radical of whatever plus 2 times the radical of the same stuff. It's just going to be 4 times the radical. Alright, so what have we accomplished here? We got rid of one of the radicals, because we started with 2. So now we need to do the same process again with this radical that's left. We need to get that term by itself, and then we can square each side. So we subtract the 2x here. So it leaves us with x plus 4 on the left. Now it's up to you. If you want to divide both sides by 4 so that radical is totally by itself, you can. However, it's not necessary, and the reason is because of the operation between the 4 and the radical. That's multiplication, because there's no symbol written there. And so if you square that right side, it's not 4 plus the radical. If it was 4 plus the radical, we would need to distribute things, and we would still have radicals left. But it's 4 times the radical. Squaring behaves nicely with multiplication. And what I mean by that is you can square each factor and multiply them together and get the same result. That's not true of squaring a sum. If you take a plus b and square it, you don't get the same thing as squaring a, squaring b, and then adding them together. But for multiplication it does work. So we can square the 4 and we can square the radical here, since it's multiplication in between. Now on the left side we have a plus. So we can't just square the x and square the 4 and call it a day. Okay, so that's the difference. We have a plus on the left, we have multiplication on the right. So we're going to end up with a quadratic here. So we'll want to set it equal to 0. And then again, I'm going to omit some steps here, but this factors as x minus 20 times x minus 4. And so the solutions to the quadratic are 20 and 4. But we didn't start out with a quadratic, so we need to check those back in our original equation and see if they really are solutions. So our original equation was this. So we need to substitute 20 and 4 for x and see if they really are solutions. So when we substitute 20 for x, we need to see if the left side really is equal to the right side. So in other words, does the left side become 2? So we end up with square root of 64, which is 8, minus square root of 36, which is 6. That does equal 2, 8 minus 6. So 20 is a solution. Let's check our other quadratic solution, which was 4. It's important to check both solutions. Sometimes these equations will have 2 solutions. Sometimes they both work. Sometimes only one of them works, so it's a good idea to always check your solutions for a radical equation. So here we have square root of 16, which is 4, minus square root of 4, which is 2. That is equal to 2. So we have 2 solutions here. 20 and 4 both work.